Welcome back to Disruptors Unleashed, where we explore disruptive technologies and chat with the trailblazers who are redefining industries as we know them. Previously, Dassault Systems expert Mahou de Villepin-Lambert discussed how the life sciences and healthcare industry can enhance innovation while protecting biodiversity. In our second episode, dedicated to biodiversity preservation, we're talking about manufacturing. Today, we are diving into how consumer goods manufacturers can reimagine biocircularity from the ground up through traceability and digital innovation. Join our expert Raymond Wodar of Dassault Systèmes as he unpacks how the 3D Experience platform enables CPG manufacturers to transform every stage of their product lifecycle, from sustainable sourcing and smarter manufacturing to packaging redesign and traceability. Given the industry's reliance on ecosystem services, how do you think manufacturing firms should rethink their raw material sourcing to align with biocircular strategies?
The CPG industry is deeply dependent on natural systems. If you think about it, for agricultural ingredients, water, and packaging materials. These ecosystems are under growing pressure, with 90% of biodiversity loss really predetermined, occurring at the start of the value chain. Many companies need to rethink sourcing through more of a circular lens. There are 5 main drivers of biodiversity loss that include land use, climate change, invasive species, exploitation of natural resources, and pollution. So that really means that the industry must shift from an extractive, linear type model to a regenerative, recycled, or certified sustainable inputs. A circular strategy helps decouple growth from raw material use, reducing pressure on forests, soil, and water systems. By embedding sustainability early in the procurement decisions and product design, CPG firms can reduce nature-related risk. So, responding to consumer demand for responsible brands and align with upcoming regulatory shifts like the EU's PPWR, which is the Packaging and Packaging Waste Regulation, which is really accelerating the move towards reusable and recyclable packaging. Many of the companies that I've worked with recently, like a global food brand, has designed packaging with more than 50% post-consumer recycled content. This is allowing them to move from extractive to regenerative, recycled, and certified sustainable inputs to protect the ecosystems that they're involved in through their supply chain. Some of the targets for PPWR are, for instance, 30% post-recycled content by 2030, and the reduction of virgin material used on a year-by-year basis.
That all sounds very promising. Could you share from your experience how manufacturing optimization strategies can help reduce the sector's impact on biodiversity?
In the CPG sector, even small improvements in manufacturing efficiency can scale to massive environmental gains due to the high production volumes in the CPG business. By using less water, reducing energy consumption, eliminating process waste in manufacturing, CPG firms can significantly lessen their dependence on natural resources and lower their impact on local ecosystems. Manufacturing optimization also allows companies to cut unnecessary raw material uses, which reduces pressure on land, forests, and fisheries, depending on the sector that they're operating in. When integrated with circular design principles like lightweighting of packaging or using recycled content, it results in tangible biodiversity benefits from bottom line savings. So it's really a win-win. A beverage company I've been working with reduces water use per liter by up to 25% through closed loop cleaning systems. So instead of using more water inputs to clean out their systems when they have to change a line, for instance, they have a closed loop system where they capture all the wastewater and recycle that to be reused in other systems in the process.
Speaking of closed-loop systems, how do smart factories fit into the circular economy and help protect natural habitats?
If you think about manufacturing plants, they can be much more efficient by using things like renewable energy. You've probably noticed a lot of companies now in various places around the world using solar panels and battery storage systems that can work with local energy authorities to limit the use of their energy from the grid. So this, of course, can reduce the burning of fossil fuels and other impacts with regards to the environment. Also, the percent of waste diverted from landfills from the manufacturing process, if those materials can be repurposed in some way or reused or recycled, this can reduce the impacts, again, on local biodiversity.
We know that the 3 Rs are fundamental to sustainability. What role does product design, specifically for reusing, repairing, and recycling, play in preserving biodiversity?
Product and packaging design are critical leverage points. In CPG, it's known that around 80% of a product's environmental impact is locked in during the design phase. So when companies design for recyclability, refillability, or even compostability, they reduce the need for virgin material extraction, and they can lower waste-related biodiversity impacts. So that might mean using monomaterial packaging to improve recycling rates, or choosing materials with a smaller land use footprint. Circular design can also enable longer lasting packaging components in reusable systems, which extends material life and reduces the virgin extraction of materials. So with regulatory frameworks like PPWR setting strict targets for packaging, recyclability and reuse, companies have a clear incentive to design products that are aligned both with biodiversity protection and circularity. PPWR is an EU regulation that's aiming to reduce packaging waste. Also, it's trying to standardize the rules across EU countries and nations and accelerate the circular economy transitions. The key goals there are to make sure that all packaging is recyclable by 2030. So at least a portion of the materials going into products are recyclable. Also, cutting packaging waste per capita by 15% by 2040. Yeah, there are other various key goals in that regulatory framework, but it's mandatory to enact things like reuse and refill targets and ban certain single-use formats and eliminate a lot of overpackaging that happens in like e-commerce type transactions.
Since reducing our reliance on new materials can help achieve biodiversity protection, how can the virtual twin help businesses optimize life cycle management and decrease material consumption?
The virtual twin really gives manufacturers a dynamic digital model of their product, processes, and also supply chains. This allows companies to simulate and optimize how products are made, used, and recovered without costly physical trials. So with accurate material models, it can also be very predictive. This is very key when designing new products with new materials when you're not sure of the outcomes. So it can identify where materials are wasted, where overpackaging may be occurring, or where substitutions could reduce environmental and biodiversity impacts. It also helps design teams explore new materials and packaging formats that meet performance goals with fewer natural resources being used. A lot of companies that I've been working with lately have been using these strategies in lightweighting products to make sure that they're not over packaging products when they ship them in the market. And this allows them to test them virtually to make sure the products will perform in the marketplace. They won't arrive at a customer damaged, but they're using less materials overall. Again, it's a good win-win. It reduces cost for the manufacturer, but also reduces the impact on biodiversity. A lot of our clients using virtual twin technologies have been able to reduce materials. In one use case, up to 12% of raw material usage has been reduced using virtual twins and optimizing materials. Also reducing the number of physical prototypes needed. I would say up to about 50% of reduction in physical prototypes has been a decent benchmark for some companies I've worked with. And again, this just allows them to use the virtual world to go through multiple different scenarios, different design considerations. Cost reduction is highly aligned with the reduction of material usage. Some of our clients have reduced their cost of goods sold up to 3% on the raw material side by introducing reuse, also doing the rationalization of specifications and using those same materials in multiple products. This allows them to reduce their cost, get to market faster, and be more productive.
Thank you, Raymond, for sharing your insights with us today. It's been a fascinating discussion on rethinking biocircularity in the manufacturing sector. From responsible sourcing to circular design and end-to-end traceability, the virtual twin drives material efficiency, reduces environmental impact, and turns regulatory challenges into business opportunities. Thank you for tuning in. We'll catch you in the next episode. Curious how manufacturing companies are achieving biocircular success? Download our ebook to unlock actionable strategies powered by the virtual twin. Disruptors Unleashed is produced by Dassault Systèmes. For more episodes, follow us on Apple Podcasts, Spotify, Deezer, or your nearest audio streaming platform. To learn more about Dassault Systèmes, visit us at 3ds.com.